All right, everybody. Welcome to the Electron Injection Podcast. This is the podcast where you should turn it off. Got nothing. Okay, you try to be cute and then it's fall on your face. Story of my life. Okay, updates in my land. I've been working on Reagan Revenge Synth, which is my 8-bit really terrible synthesizer, which I'm trying to put a interface more like a Moog. An interface where you got zillion knobs and, well, more. I kind of went a different approach. I went with one encoder, but lots of buttons. So you select one feature, and you can basically keep one hand. Where's my hand? You can keep one. Is it backwards? You can keep one hand here, and I'll show you later on when I get it going. But I ran into mega trouble with this low frequency oscillation. It was just this. When I say low frequency, it was centered at 7 hertz usually, but it had energy up at 20 hertz somehow, and octave harmonic-y stuff, and it turned out to be a true disaster to troubleshoot because I thought it was an op-amp stability issue. I've made op-amp amplifiers before, but I'm not an expert at it. And I am aware of this phase margin business, and I started to go down that rabbit hole. Started to see flashbacks of control systems, a class I had in school, which is not recommended. It's kind of horrible, and useful somehow, but I just don't know how. Magical and horrible. And so I thought it was op-amp stability, so I'm tearing into op-amp math and trying to figure out how to compensate with capacitance because I've got some thing, excessive phase shift. Long story short, it wasn't op-amps at all. In fact, it was just a line of code. I had a register that was supposed to be 0, and it wasn't. And that cost me, I don't know, a week of work. I'm not real thrilled about that, but I guess there's nothing I can do about it. And here's the problem, is normally when you work with an audio source, you can turn the audio source off. Well, I thought I was. In this case, the audio source was a synthesizer chip. And because I'm working with a device that makes audio, the thing making the audio was the problem, not the op-amp. So it's a long story, but it just required troubleshooting where I had to tear out basically most of my PCB to find it. What's weird, though, is this wasn't a problem on the breadboard before. It's only on the PCB. So this gets into that problem where, I'm using these Chinese chips. I've got the YM3812 synthesizer chip. It's a classic 8-bit terrible sounding chip, which is what I want, but you can't get them new. You can't get them on DigiKey or Mauser, and so it's like, well, where do you get them? And you don't know what you're gonna get. So not all chips required this register to be cleared, and so that was very interesting. But we found it, we solved it. Now we have a functioning monophonic synthesizer, and soon we should have a functioning polyphonic synthesizer, hopefully today. All right, so enough about me. Last week we talked about the STM32 Blue Pill and how it's my favorite microcontroller. It's in my Reagan's Revenge synthesizer, for example. I love working with that particular microcontroller. I think it's great as long as you can get a good one. And I guess we'll go over that here in a minute, but because I kind of want to revisit that some. But all the rage in the interland of Twitter and whatnot has been, and YouTube has been about the Raspberry Pi Pico. And let me show you that. How do you switch these buttons here? There he is. And you can see the form factor, the shape is very similar to an STM32 Blue Pill. I don't know if it's identical or not, but it's pretty damn close. And so it is. It caught my interest. And so let's talk about how the Raspberry Pi Pico compares to the STM32 Blue Pill, because this is a pretty exciting time. Let's just say that. All right. So does the Raspberry Pi Pico kill the STM32 Blue Pill? That's the big question today. So let's recap. I'm going to read a lot of this. The Blue Pill. We have some good things. The Blue Pill is about 4.5 times the speed of an Arduino Uno. That in itself is pretty cool. It offers debugging for about $3. Real debugging where you can step through the code, not just the serial stuff. Well, the serial stuff's valuable too. I like both. You can buy the legit debugger for the Blue Pill for $12 on DigiKey, by the way. The clone is the $3 one. I have 2 clones. They've been perfect for me, so, whatever. The STM32 Blue Pill has plenty of SPI, I2C, and serial peripherals. Got interrupts on every pin, and about half those pins are 5 volt tolerant. Pretty cool. Downsides of the Blue Pill is the price is too good to be true. Am I complaining about a $2 microcontroller? Yes. Why is it only $2? It's $5 on DigiKey. Something's up. And fakes and counterfeits are everywhere. It's hard to find a $2 blue pill without weird white goo on the bottom, where somebody's been, resoldering, desoldering, fluxes. Something is up with that goo. I'm not exactly sure what it is. It doesn't look like anything you get from DigiKey, that's for sure. And so because of all this, reliability is hit or miss. You plug one in, it may be dead. You plug one in, it may be dead in a month, and that's where it gets messy. And I mentioned this last week. I made my wife a little acrylic little flower thing with blinking LEDs underneath it, and that whole the whole lit up acrylic thing. Probably should dig up a picture. Too late now. It's a damn podcast. We're going live, boys, girls. And the damn thing died, and I had to rebuild the whole freaking project because of what ended up being a voltage regulator. And that's one of the big problems with the STM32 is the voltage regulators they put. It's not STM32. It's just these blue pill cheapos you get from AliExpress or whatnot. But the voltage regulators on them usually stink, and they die even if you don't push them. But so I always use my own external regulators, which is easy to do, and that helps for sure. But once you get a good one, you have a hell of a platform. What a good setup for a few bucks. But you do have to kind of wade through it, and it's a problem during troubleshooting because you never really know if you got a good one or not. It's always in the back of your mind, and you're always thinking, man, is the circuit screwed up because of me, which is always the case, or is this actually a bad chip? And so it's that throws a curveball into your thinking, and it makes building things less fun. That's for sure in that regard. So let's get to this Raspberry Pi Pico mess. Here, I'm going to switch some screens around because I think we might actually have value in some of these. So let me do this. All right, let's push that button. So yeah, we're back to the Pico here. Okay, here's the great thing. Excellent documentation. And if you go to their, I guess it's the standard Raspberry Pi Pico site, like you see here. Transform. I'll make this a little bit bigger. Let's make this giant because this is a video. We get all the specs, and I'll be running through those here pretty quick. Or maybe we just kind of freestyle this. Okay, so yeah, we got dual core, which don't ask me how you fully utilize a dual core on this thing, but 133 megahertz a pop. That's a lot. That's basically double the blue pill, and we get two of them. So if you can figure out how to harness those for your projects, you're looking at essentially 4 times the processing power. 256K of RAM, that's a lot. 2 megabytes of onboard flash memory, that's a whole lot. Now here's one that we need to talk about too, it's a big one, is this castellated module allows soldering direct to carrier boards. What does that mean? Well, he's castellated, it's kind of hard to see. Maybe if you go here, can I zoom mega in? Nope. Okay, well, right here, there's a curve. You see that? There's a concavity, concaveness to all these pins. So you have the circle where you stick your normal headers if you want to put this on a breadboard or whatever, which is how I have to do it with the blue pill. I don't love that. I don't like headers. What this means is you could use surface mount. You could just have pads, little square pads, and you can just set this thing down and solder directly to the board. And so that means you could do this with mass production, for example, or at least more mass production than most of us deal with. That's suddenly interesting if you need to produce, 300 of a product. Well, you don't want to have to solder all, 300 of these by hand. And so instead, you can use these castellated, is it holes? Yeah, castellated mounting holes. I forgot the terms for these things. I'm bad at names. This lets a pick and place machine install this thing for you. Pretty damn cool. So let's zoom back out. So that's a big thing. Like, they thought of it. This is what I like about this Pico is they've been thinking on a level that how can we push the bar up another notch? And I don't see that all the time, and I'm really impressed by it. All right, and so it's got USB 1.1 type support for whatever you'd use that for. Now they have a low power sleep and dormant mode. I'm going to wait on that. All right, because and it does allow this drag and drop programming thing with Python. And again, we'll talk about that here in a second. 26 GPIO pins. That's pretty cool. That's right in the ballpark of the STM32. I don't even know what the blue pill actually has. It doesn't really matter as 24 or 26 unless your specific product requires it. So for most of us, who cares? It's got plenty. 2 SPIs, 2 I2Cs, 2 UARTs. That's all good. The The Blue Pill has 3 UARTs, but yeah, you could get by with 2. It's not a big deal. It has 3 ADCs. 3 ADCs is not a lot, but it's not nothing. That's good. I wish it had 4, but I wish I had $1 million. It's one of those things. 16 controllable PWM channels. That's good, just like the Blue Pill. Not sure about all this temperature sensor business. Floating point libraries on chip. Sounds interesting. Who knows? But overall, the specs look really damn good. And I guess this is a time as good as any to talk about the price. The damn thing's $4. $4 for a full-blown microcontroller like this with this kind of specs. It's unheard of. It's crazy. So, and again, $4, not AliExpress $4, where God knows what kind of communist infiltration we've got, a government sub. It's weird. It's weird that things are that cheap. That's all I'm going to say. So, at $4 for a legit company that backs up their stuff, that not fakes, that changes everything. I mean, everything. Because that's the struggle. Like with my Reagan's Revenge synth, I've got big plans of selling this thing, and maybe I'll sell 100 or 1,000 or whatever. Well, what am I gonna do? I started with the STM32 Blue Pill because I like it, but because I had to go through those things manually, a part of me was like, well, maybe I could design a test jig and so I could test like 8 of these at the same time, and then only in a few hours I could test a few hundred and throw out all the junk. I mean, that's not the right call. And it sounds like Raspberry Pi Pico has solved my problem. And they even have, you can buy these things on the reels. I don't know if it's worth Googling this. Let's see. Pico reel. How do you spell reel? 2 E's. Okay, Raspberry Pi. Let's just see if this comes up with anything. Because it's, yeah, here it is. Oh, the future. Can we see that big? Come on. Oh. Well, damn it. Sorry I'm wasting your guys' time. Time is money. And again, I'm kind of struggling between how much to do things YouTube-y, video-y, and how to do things audio-y. So if you guys can't see this, I guess tough crap. You know how that goes. So so anyway, they come on the reels, which is the same reels you get any SMD part on, except these are really big and fat. Again, they thought of this thing through. So if you wanted to mass produce stuff, you can. You buy a reel of them and ship them over to your pick and place manufacturing place, and they'll set it up for you. So do all the work for you, automatically, robotically. I think robotically is better than automatically in this case. Okay, so I'm going to switch back to me. And so a few things that they didn't really talk about on the documentation that I think is huge, and I'm going to probably kind of cover. I kind of went out off my script, and now I'm going back on my script a little bit here. So yeah, reliability is going to be a big one on this. It's good. We can trust these things. We can trust the Raspberry Pi. They're a proven. They're not even a company. I guess they're a nonprofit organization. Here's the awesome one: is the voltage this thing takes. You can give this 1.8 volts to 5.5 volts, and it has a buck boost converter on it. And for you guys that are new to this, a buck converter knocks voltage down. It's a switching type of converter like in your cell phone charger. And so it's extremely efficient. Might be a little bit noisy, but we can always work around that usually. But it's knocking 5 volts down is normal. Everybody has to do that type of thing to get down to 3.3 volts or whatever this microcontroller needs. But the cool one is you can give it too little. So if you only have 2 volts, this will boost it up to 3 volts. And that's the boost part of it. So that's called a boost converter. I did my senior research project in school, in college about that. It's pretty cool technology. Well, this thing can do both. What does that mean? Well, it means you can power this thing with a phone charger if you have a stationary at home type of thing. But if you use batteries, battery voltage starts out high, and then over time they drain. And what happens when they drain is very tricky. It's I would say scary at times if you've done any battery type stuff, and you have to. Long story short, this is great if you're powering your project with batteries. The only problem is it ain't free. The buck boost converter, it's not bad in dollars, but it's bad in terms of current use. And so we're going to get into that here in a minute. Maybe I should just cover it now is the low power aspect of this thing. From what I've seen in the data sheet, we're looking at about 1 milliamp is approximately the lowest you're ever going to get current on this thing. Now, you might be thinking, 1 milliamp, that's nothing. It won't even kill you. That's true. It will not kill you, I think. But 1 milliamp, a lot with embedded stuff that, I don't know, if you want the battery to last a year, you're looking at you need to be down like in microamps, nanoamps, those types of things. And even the Arduino Uno, if you get bypass their voltage regulator, you can get it down, into that ballpark. So we'll have to see how that goes. So if you're doing hyper low power stuff, this may not be the chip for you. Most of us can handle 1 milliamp, and there's so many pluses to this thing that most of our most of our home hobby projects, if it sucks a battery in 1 milliamp at a time, and maybe in a month the thing dies, we can usually live with that. A lot of my little trinkets I make for the wife are kind of like that. I use batteries and they just die in a month. So what? So 1 milliamp is not terrible, but it's not what I'd call low power. It's kind of low power. So that's a downside. I wish they would have figured out a better solution, but it's offset by the fact that we don't have to think about too low or too high a voltage. So it kind of goes both ways. All right. So yeah, and the footprint is small, plenty of GPIO. We like the castellated mounting holes. We love the performance. Dual core 133 megahertz, 264K RAM, 2 megabytes of flash, 16 pins of PWM. I haven't found if those are 16-bit or not. I'm just going to go out on a limb and say they are 16-bit, just like the Blue Pill. Just a hunch. Because this is based on the the Cortex M0 processor, which is, I believe, the same thing that this is the Plus, STM32 M0 Plus. Correct me on that if you know. Put it in the comments or whatever. So here's another cool one. This is kind of the stuff that doesn't get talked about as much. Is you have multiple pin out options. Let's switch it back to the old thing so I can. Here we go. So when you look at the pin out on this thing, you can see that we have SPI 1 clock on GPIO 10, which is number 14 on the I guess you can call it pin 14. Then we also have SPI 1 clock on pin 19. Of course, it doesn't do both. You pick one. And this is common with a Blue Pill. Blue Pill could do this in certain instances. You can do that in the STM32 Cube IDE, for example. But I don't know if in Arduino you may not. So I'm not really sure how we configure this, but it's like this with lots of things. Lots of things have redundant pins so that you can pick one or the other. And this is very helpful for layout. So you can, if you want to keep all your layout on a 2-layer board and you don't want to tear up the ground plane on the bottom, well, then you can adjust your pins around so that the tracks don't overlap. This is big. It's a big deal. And it could be the difference between using a 2-layer board and a 4-layer board. You're looking at real cache then. So that's cool. So again, somebody put some real thought into this. I'm really excited about that. All right, so what else we got here? Programming. It offers programming for C and C++ through the SWD port. It's a standard type port like the Blue Pill. It's not hyper clear what debuggers are going to work with this thing right now, but it does say in the manual that you can use another Raspberry Pi Pico as your debugger. Well, that's pretty cool. So the jury's kind of out on this, and these are the types of things that it will kind of, with 1 billion people working on this thing this month, probably I would assume in a month from now, maybe by the time you hear this, we've already got all kinds of little gadgets that solve any of the pain in the ass problems. So the debugger, if we can use a Pico, that means the debugger's $4. That's within spec. That's totally cool with me. So awesome. We're going to get into some of my gripes, so I'll just hold off. Okay, so the bad news. Bad news is good luck getting one. They're out everywhere. Now, if you try to build anything in electronics this month, here, February of 2021, 1 year of COVID, give or take, then getting any electronic component right now is a pain. Ford has shut down multiple plants because they don't have the circuit boards. They don't have the electronics they need. And some say it's because of extreme demand, and I don't know if it's a supply or demand issue. I haven't dug into this enough, but we're definitely having shortages in electronics, and this is no exception. Of course, this just came out, and everybody's excited about it. Everybody's talking about it. So hopefully, in a month or two, it'll be easy to get these things. We shall see. At the moment, there is no Arduino IDE support. I hear it's on the way. I don't know how long that takes. I don't have a clue what it takes to port something like this to Arduino. we'll see. And so at the moment, the last I read, and I hope this is accurate, there is no support for Platform IO. And of course, that's my favorite IDE. I prefer to use Platform IDE with Arduino framework because, well, that's a whole other discussion. But that's my preferred thing, although I can't do the real stuff. Unfortunately, there's just no IDE for this thing. So if I wanted to program bare metal, if I wanted to program, at the lowest level, highest performance we could get, the deep stuff, they don't offer an IDE for this thing. And that's kind of become the commonplace behavior in the past, I would say, decade. Atmel has their own IDE, and they actually have two now. They're microchip. STM32 has their Cube IDE. Simplicity Studio for the EFM8s. I mean, everybody has their own, and they're all usually based on some kind of open source Eclipse. Texas Instruments has their own, their Composer. So it's you're used to open up the IDE and the microcontroller pretty much just working. You push a few buttons and you're in. And if you're starting up from scratch, it's a lot harder. And that's kind of what they've done, it seems like, with this Pico, is they've taken the approach like 10 years ago or so. Before, it was common to have IDEs perfectly configured, and so you have to more or less manually configure your IDE for this thing. You got to set up the linkers and all this stuff. Now, a lot of pro people say, what's the big deal with that? That's no trouble. Well, it is trouble. And even like Ben Heck, he was ranting and raving on his review of this thing. He's like, gee, setting this up is a disaster. I'm not just quoting him, paraphrasing him, I should say. But he wasn't real thrilled about the pain in the ass factor of getting this to Blinky with C or C++. So if you're going to write in C or C++, get ready for maybe not a war, but you're going to have to put a little time in to figure out how to set it up. And that, I hear it's a headache. People don't like that part at all. So again, it's early. We'll see. But that's the type of thing I wouldn't expect right away. And this is Raspberry Pi's first microcontroller, so I don't think they're just going to, run out and throw out an IDE try to launch an IDE the same week they launched their microcontroller. So we'll see. They might. I predict in a year or two maybe they'll have something, or at least somebody will have it much more simpler than it is now. And of course, if it's on Arduino IDE, then we could pretty much get that into Platform IO, I think, and then I'll be set. I'll be. So I'm pretty excited about that, but right now it's a little early. So, in other words, programming this thing with C or C++ is going to be a little bit of a hassle, and that kind of leads us into other options. What's our choices? And MicroPython is where they're pushing us. And everybody says if you do MicroPython on this thing, it's just bam, bam, 2 seconds, you have Blinky. Like you're in. It's good. So everybody says the pain in the ass factor with MicroPython is nearly nothing. I think it's MicroPython, or is it CircuitPython? Let's Google that real quick, fellas, ladies. Let's see. Raspberry Pi Pico Python. It says Python. What's this one? MicroPython. Okay, not CircuitPython. I'll lose track of who's who because there's two, different competing factions. Bitcoin hates Litecoin, whatever. Okay, so with MicroPython, apparently this thing's good to go. Now, Ben Heck did test the Blinky, and it was way slower with MicroPython in terms of blinking. It was in the kilohertz range, not in the megahertz range like he was getting with C. So we're going to have to see how slow that is and what libraries are there. I don't know much about MicroPython. I've never used it. I love Python, and I would definitely try it on a microcontroller. And of course, for me, I'm wondering, well, I'm used to using the Arduino framework, which is definitely slow. I don't know if it's slower or faster than Python. And so basically I'm wondering, well, can I get my synth to work with Python? Because that would be really fast and really easy. So that's just another alternative, which is nice to have. If you're going to just do some quick and dirty stuff, then bam, 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 you can bang out a Python script in 10 minutes. It might take you 5 times that long in C or whatever. So anyway, let's see. So yeah, basically the setup's a real pain on this thing. So yeah, we're getting kind of like at the point where I guess I can go ahead and wrap this thing up. It's way faster than a Blue Pill. It's reliable. It's from a real company. It's only $4. which, maybe about double of a Chinese clone STM32, I will gladly pay an extra $2, $1.80, whatever. I'll gladly pay a few bucks extra to know that I have a legit product, that if it's broken, it's almost guaranteed to be my fault. That is a great, great, great burden off my shoulders. The fact that it has the castellated little pins so that we can use a manufacturer to mass produce this if need be, that's great. But I could still use headers if I want to. That's great. I can move pins around if I need to make the layout smoother. That's great. 3 ADCs isn't a ton, but it's enough. I mean, we can make that work probably. And if we need more than that, well, that's something we probably should talk about too. The STM32 could scale, and I was big on this. If you learn the Blue Pill, then you can do your own PCB, and you can just roll off any microcontroller you want. And of course, the STM32s go way up here, they go way down here in terms of performance. They have a whole family, and the learning curve from jumping to one to the other is minimal. That is awesome, and that is definitely something we lose with the Pico. But the Pico is fast enough. I mean, it's more in like black pill territory. It's fast enough where you never really, I shouldn't say you never need to go faster. You certainly can, but it's going to cover a big, wide chunk of the projects you're going to ever encounter. The lack of nanoamp, microamp level low power is kind of, it's not perfect. I don't love that. But again, we can make that work the most of the time. And if we can't, we're just going to have to go to, other options where we can get into that nanoamp region. But the fact that the voltage regulator lets us go from 1.8 to 5.5 volts, that takes a huge burden. It's one less thing to deal with. That's very nice. So overall, I think this thing is a winner. And I don't have one. I don't want to pretend I do. I probably should have said that at the beginning. Just looking at the specs and the data sheets and talking to people online and whatnot, the thing is definitely a winner. They got something good here. And with just a few little refinements just to simplify my life, let's get this thing in a platform I/O, preferably with the with the Arduino framework, and then I'm totally in. Like, this might be my go-to microcontroller, which in a way sucks because I committed to the STM32. I go, here we go, we're gonna run with this. We found our guy, and or gal for you gals. I found my microcontroller I'm just going to stick with. And now if something better comes along, it's like, well, crap, I guess I'm just fickle and jump ship. So definitely take a look at it. This thing is real deal. They've done apparently a great job. People are thrilled. People are doing some really wicked projects, and because of the power, you can do processing power. You can do some really cool video stuff with it even. So you're kind of getting into that multimedia land where you can crank out some impressive graphics and whatnot. So it's not just an Arduino where you limited to 8-bit stuff. So highly recommended. Check it out. And as always, follow me on Twitter. I'm actually active on Twitter now. I'm doing it. I've used Twitter every day for the past 2 weeks. And I'm actually loving it. I've just learned you just ignore all politics. And I like politics stuff. I have my own views on almost everything. But that's a separate deal. So I keep my Twitter out of that because Twitter will ruin you if you get into political stuff. But talking only about electronics with other engineers has been great. So follow me on Twitter, Brandon_Drury. And of course, hit like here on YouTube and all that crap. I'm trying to make a living here, people. I'm trying to help. And if you like what I'm doing, tell me. And of course, you can subscribe to the podcast through all those RSS type feeds and iTunes and all that sort of jive. All right, over and out. See ya.